Greetings, math fans. All right, so today is day 2, and what we're going to do is we're going to talk a little bit about composite functions. So remember yesterday we talked about the chain rule? Well, it's kind of the same idea. Okay, so first of all, let's just do an exam, or just kind of show you what's going on here. Right, this, of course, means f of g of x, right? Some people say fog, right? F of g of x. I don't know, that's the way it looks. All right, so the deal is you need to remember the chain rule. Okay, so remember the chain rule. So what we're going to do is we're going to say f of g prime of x. And remember what it is. You take the outside first. So we're going to take f prime of g of x. Right? So again, I don't touch that inside. I take the derivative of the outside. Remember we had that u substitution where we bring the u down, to take the exponent down and use the power rule, right? And then we do the inside. So it's f prime of g of x times g prime of x. Okay? And this being the outside, and this being the inside. Okay, so let's just do a nice little friendly example here. If I give you f of x is equal to x squared plus 4, and g of x is equal to 3x minus 5, and if I said f of g prime of x, that's going to be, this is our outside here. So we do the outside first, which is going to be 2. And remember, then it's g of x. So we're just literally putting, wherever you see an x now, you put g of x in there. So it's 2, it's really 2x plus, or just 2x, right? So it's going to be 2, and what's x? The inside. The inside is 3x minus 5. And then I take the derivative of the inside, which is my g prime of x, which is just 3. Okay? So again, this part right here, when I did this back in the day, that was like saying, what's the derivative of u squared plus 4? You just said, oh, it's 2u. And the value of u, which was the g of x, so 3x minus 5 goes into that spot. That's why it's 2 times 3x minus 5, then times the derivative of g of x, g prime of x. All right? And so if I simplify that, let me just kind of go down here a little bit, I get 6 parentheses 3x minus 5. Okay, not bad. And then, of course, I can say, what is f of g prime of 3? It just means you put a 3 in there. It's no big deal. So 6 times 3 times 3 minus 5, or 6 times 9 minus 5, so 6 times 4, which is 24. All right? Now, one quick thing. This is really, really key. I'm going to write this in red. And I have this note in my notes because I've seen kids make this mistake. F prime of g of x. Okay, this is not multiplication. And I know some of you guys are like, well, duh, I know it's not multiplication, but sometimes people look at it as opposed to plugging in g of x into whatever the function is for f prime. Sometimes people try to multiply things together. And I've seen that happen in the past, so I'm just telling you now, please don't, it's not multiplication, it's f prime of g of x. Okay, it's a composite function. So don't forget that. All right, so what I'm going to do now is we're going to do this is like a chart example, and so I'm going to write in the corner here. If you guys can make 5 columns, and 5 rows. So I guess that's going to be enough here. Just have to kind of crunch it in, but I don't want to take up too much room on my screen here. So 1. Yeah, I'm going to have to make 1 more. Okay, so we're going to have x, we're going to have f of x, we're going to have g of x, we're going to have f prime of x, and we're going to have g prime of x. Okay, my values of x are going to be 1, 2, 4, and 12. And going down, 3, 7, 11, and 1, 4, 8, 2, and 2, 5, 9, 13 and 3, and 6, 10, 14, and 4. Okay, so we're going to do a bunch of different problems based off of this chart. So it's like me handing you the derivatives and the actual functions and the derivatives at values of x equals 1, 2, 4, and 12. So here's my first example. I'm going to try and fit everything on here. d by dx of f of 1. Well, that's really easy. Just look at the chart. It's the derivative of f at 1 is equal to 5. That's pretty easy, right? Just kind of look at the chart. Okay, here, how about d by dx of 2 times f of 2? Again, that's pretty easy. Just f prime of 2 is 9, so it's 2 times 9 equals 18. Brutal! Actually, it's really easy. All right, so let's do a little more brutal problem now. Now that you're feeling all friendly here. F d by dx of f of 1 times g of 1. Okay, so what are you going to do here? Don't just plug in a 1 into f of 1 and g of 1 and then take the derivative. I mean, you can't do that. What do you have to do here, math fans? You have two functions. You have multiplication. You're going to use the product rule. Okay, so it's going to be the first. So let's show a little bit of work here. It's the first times the derivative of the second plus the second times the derivative of the first. Ah, that's pretty easy now, because now we're just pulling all this stuff off the chart. So f of 1 is 3. G prime of 1 is 6 plus g of 1, which is 4, and f prime of 1, which is 5. So it's 18 plus 20, which equals 38. It's not bad. Okay, so let's do the next one here. d by dx of f of 2 plus g of 2. All right, do I have to do anything special? Actually, I don't. Really, can I just rewrite this, math fans, as d by dx of f of 2 plus d by dx of g of 2, right? That's our rules. We can split that up, the derivative, into separate derivatives. Okay, so that's really pretty easy. Just plug it in. So it's the derivative at 2 of f is 9, and the derivative of g at 2 is 10. So my answer is 19. Okay, really pretty easy. All right, I got a couple more here. I'm going to put it up on top here. D by dx of f of 1 over f over g of 1. Okay, what are we going to do here? We're going to do the quotient rule. So let's actually just write it out. I think it's a good thing to write it out. It's bottom times root of the top, so times f prime of 1, minus the top times root of the bottom, all over the bottom squared. And so we're going to have, let's see, it's going to be 4 times 5 minus 3 times 6, all over 4 squared. Sweet. And you simplify all that and you get 1/8. Okay, it's not bad. I got 2 more examples here. I'm just going to delete this stuff now. It's going to go in an instant here. Okay, so we're going to do d by dx of f of g of 1. Okay, just got to remember our old rule. This is the first thing we did in class, math fans, right? The derivative of that is f prime of g of 1 times g prime of 1. All right, so basically what you're doing is you got to do g of 1 first, and g of 1 is 4. So it's really like saying f prime of 4 times g prime of 1, and f prime of 4 is equal to 13. G prime of 1 is 6, and so we get 78. All right, and then our last example using this chart is d by dx of f of 2x plus g squared of x. Oh man, this is looking brutal here. Okay, and then That's it. Okay, so it's the derivative of f, and that f is that whole function here. All right? And so what do we have to do? And I need to do it at x equals 4. So this looks a little tough, but it's really not that bad, math fans, as long as you remember to use the chain rule. So we're going to go from the outside to the inside. So truly what I have is, I'm going to kind of go across here because I need to have enough room here. So it's really f prime of 2x plus g squared of x. Okay, and that is the outside. I hope you guys agree with that. That's the outside. And then what I want to do is I want to take the derivative of the inside. So it's times, and what's the derivative of 2x? 2. What's the derivative of g squared of x? Well, that's it's a little complicated, but not really. Don't just use the power rule. So isn't it times 2g of x? But here's the extra little tricky thing. Then I got to take the derivative. So using the chain rule of g squared of x, isn't it 2g of x times g prime of x? Because I have to take actually the derivative of that function then too. Right? I use the power rule to bring that 2 down, but then it's g prime of x. Okay? So I plug some values in now. So it's f prime of 8, because put it, what am I putting in here? 4. Putting a 4 in there. So 2 times 4 is 8 plus g squared of x. So let's just show a little work here. G squared of 4 times 2 times 2g of 4 g prime of 4. So we're going to do f prime of 8 plus, well, what's g of 4? That's really saying g of 4 squared, right? So g of 4 is 2, and then it's squared, so plus 4. Okay, everybody okay with that? I hope. And then it's times 2 times 2, so that's going to be 4 times g of 4 is 2. G prime of 4 is 14. And so let's keep going here. It's f prime of 12, and f prime of 12 is 3. So it's 3 times 4 times 2 times 14, so that's 58. And 3 times 58 is 174. Okay? It's mainly algebra, math fans. Really, really algebra. Just kind of be careful with what you're doing here. Okay? All right, let's do some good chain rule examples here. We did one with a chart, but I want to do some other examples. All right, so I'm going to title this Good Chain Rule Examples. So the first one is y equals sine of 2x to the 4th. Okay, and d by dx. Again, you're doing the chain rule, so always work from the outside in. So derivative of sine is cosine of 2x to the 4th, right? Keep that inside intact because you're not touching that. And now, once you took the derivative of that sine of u, then you take the derivative of whatever that value is for u. Well, u happens to be 2x to the 4th, so it's the derivative of 2x to the 4th, which is going to be, you bring the 4 down and you get 8x to the 3rd. And you really want to rewrite this then as 8x to the 3rd cosine of 2x to the 4th. Okay, and that's your answer. All right, second example, y is equal to sine to the 4th of 8x squared. Okay, so math fans, I'm going a little deeper now because the first one I had to deal with the sine, and then I had to do the inside. Now I want to rewrite this as y is equal to sine of 8x squared, and that's the 4th power. Okay, because if we rewrite that now, I actually have 3 levels deep, and I'm going to do is I'm going to take that 4, and I'm going to, by using the chain rule from the outside. Okay, so let's write dy dx. That's going to be 4 times the sine of 8x squared to the third power, right? Do you see that? That's like saying u to the fourth power is 3 or 4 u to the third power. All right. Now I'm going to take my next level is actually using the sine. So it's times cosine, and again, I'm not touching that inside now yet. So it's cosine of 8x. And now I'm working my way from the outside all the way inside, and the derivative of 8x squared is 16x. Okay? And then you kind of put everything together to make it nice and clean, and you get 4 times 16, so you get 64x sine cubed of 8x squared cosine of 8x squared. Okay, and that's your answer. All right, but you got to make sure you do all the derivatives. Okay, you work your way in, and which I'll talk about right at the end, but don't make the common mistake of keep taking the derivative. Sometimes what happens is people get to even to this point right here, and they're like, well, then they do this, they get the 16x, but then they try to take the derivative of 16x. And I'm like, why would you do that? Because all of a sudden you take the derivative of 16x, you get 16. Well, why not just keep going? What's the derivative of 16? Oh, it's 0. Hey, the whole thing goes to 0. Okay, you're not going to, it's silly. You don't do that. Don't keep taking the derivative. You do it only one time. Otherwise, eventually it's going to cancel out, or it's just going to get brutal on you. Okay, so don't make that mistake. All right, let's do third example here. Y is equal to cotangent of 3x to the fourth minus 4x. Okay, so dy dx is equal to derivative of cotangent. Again, there's no exponent on the outside, so I don't have to worry about that, but it's negative cosecant squared of x, which is, or u, if you want to look at it that way. So 3x to the fourth, 3x to the fourth minus 4x. And then I take the derivative of the inside. Well, it's the derivative of 3x to the fourth. That's 12x cubed minus 4. Okay, so you can simplify it negative, and you get 12x cubed minus 4 times cosecant squared of 3x to the fourth minus 4x. Okay, it's not too bad. Not too bad at all. Okay, let's try number 4. Okay, so y equals the square root of 2x cosine of x. Well, definitely you want to rewrite to not have a radical. Okay? And so we're going to write it as y is equal to 2x cosine of x to the 1/2 power. Okay, and apply the chain rule. Very simple. Dy dx is equal to move the 1/2 in front, and we're going to get 2x cosine of x. Again, I'm not touching anything on the inside, and it's to the negative 1/2. And then I take the derivative of the inside. Now, what's going on with the inside? It's the product rule. It's 2x and cosine of x. So it's the first times the derivative of the second, which is negative sine of x, plus the second times the derivative of the first. Okay, a little messy, but let's kind of scroll down here a little bit. Let's put some stuff together here. We have 1 over 2 times the square root of 2x cosine of x. And I don't care if you leave it as rational exponents. I just turn it back into a radical. Just when you're doing the derivative, it's nice to have it as a rational exponent. And then it's times negative 2x sine of x plus 2 cosine of x. And we're going to put this all over 1 just to show that we're going to kind of put this all together here, because all multiplication. And so really we just get, and I'm going to simplify one more shot here. Negative 2x sine of x plus 2 cosine of x over 2 radical 2x cosine of x. And what can you take out here? You guys can take out a 2, right? You can factor out a 2, so they're out of here. So my final answer is actually negative x sine of x plus cosine of x over the square root of 2x cosine of x. Okay, and that is my final answer. You know, it's a little messy, but not really. I mean, again, there's a lot of algebra involved here. All right, let's do example number 5. y is equal to cosine to the fourth of 2x times secant squared of 6x. All right. So again, I think it's a good idea to rewrite this as, just to help you out, cosine of 2x to the fourth power times secant of 6x to the second power. All right. So dy dx. It's going to be the product rule. So we're going to do the first, which is cosine of 2x. The first times derivative of the second, which is secant of 6x is secant x tangent of x. Okay, but before you even do that, what do you have to do? Okay, I'm going to highlight a couple things here. Do you guys agree? I mean, that's why this one's a little complicated, because you actually have the power to deal with. You have to work the chain rule, work from outside in. Okay, so it's actually a really good problem. So it's times 2 secant of 6x. Okay, and that, of course, the exponent goes down to 1 then, right? And then I take the derivative. What's the derivative of secant of 6x? Isn't it secant x tangent x? So it's secant of 6x tangent of 6x. And then what do you do with that? You multiply it by derivative of 6x, which is 6. Okay? Now, we're only halfway done, because we have to use, I'm doing the product rule. So it's the first time derivative of the second plus the second. So plus the second, so it's secant of 6x squared times derivative of the first. Again, got to use the same rules. So it's times 4 cosine of 2x to the third power. The derivative of cosine is negative sine of 2x. And the derivative of 2x is 2. Brutal, brutal, brutal. Okay, well, you're going to put as much as you can put together. You want to do that, right? dy dx then is going to give you, let's see, if I kind of multiply all this stuff together, and a couple things we're going to cancel out here. So let's write this out. So it's cosine to the fourth of 2x. And you guys see, let me highlight a couple things here. Here's a 2, and here's the 6. So really the number in front of this is 12. You guys agree with that? So it's 12 cosine to the fourth of 2x, and then it's secant of 6x and secant of 6x. So isn't that secant squared of 6x? And then times tangent of 6x. I'll put this in parentheses here. Okay? And then plus, and we're going to put some of this stuff here together again. Let me highlight a few things. Right, it's 4 and 2, and the negative. So we're actually, this is minus 8 secant squared of 6x, and then cosine cubed of 2x, and then sine of 2x. Okay? And really we can't do anything else to simplify this. No other like terms to combine, and so this is it. This is our answer here. Okay, again, it looks kind of nasty, but you know, just watch your signs and everything, and put everything together, and you're kind of good to go. All right? I got one more example to do with you. This is example number 6. I have y is equal to sine cubed of the cosine to the fourth of 2x. So if I actually had to count how many levels deep this is, let's do that. We definitely have the cube for sine, so that's 1. Then we got to take the sine, that's 2 levels. Then we have the fourth power for the cosine, that's 3 levels. Then we have the cosine, that's 4 levels. And then we have the 2x, that's 5 levels. So we actually are 5 levels deep with this problem when you're taking the derivative. Okay, so that's a lot. So actually, I want to rewrite this. So y equals, just because I think it's easier that way, the sine of the cosine of 2x, and that's to the fourth power for cosine and to the third power for sine. So dy dx, you're going to put the 3 times the whole thing, sine of the cosine of 2x to the fourth power, and then squared. Right? That's the first step. So that's the power coming down. And then I take the derivative of that. So the derivative of sine of that, isn't that just cosine of the cosine of 2x to the fourth power? Right? Okay. And then I keep going here. So now I'm going to take the derivative of the inside. So I have cosine of 2x to the fourth power. So it's, and I'm going to just put the times down here because I'm running out of room here. So it's times, and the 4 comes down, and I get cosine of 2x, and then that's to the third power, right? And then I take the derivative of cosine, which is negative sine of 2x, and then I take the derivative of 2x, which is 2. Whew. Brutal, brutal. But let's highlight, right? This is the power rule. This is the derivative of sine. This is the power rule. This is the derivative of cosine, and this is the last inside step, derivative of 2x. Okay? And you put all together, this is all multiplication, and I can't stress this enough, math fans. This one's all multiplication. And so we get dy dx comes out to be negative 24 if you multiply all your constants together. And let's write it out nicely. So it's sine squared of the cosine to the fourth of 2x times cosine of the cosine to the fourth of 2x times cosine of 2x sine of 2x. Brutal, brutal. But that is my final answer. Okay, so it looks a little complicated, but again, it's just a ton of algebra. I want to talk about a common mistake here. Okay, common mistake is this. Y is equal to cosine of 5x cubed. And I'm telling you this because I don't want you to make this mistake. So dy dx is equal to negative sine. Okay, we're good to go. So negative sine of 5x cubed times the derivative of the inside, which is 15x squared. And then what I do is I get people that do this. And I already mentioned this before. They try to take the derivative again. You guys need to understand, this is the first, this is the outside, and this is the inside. Don't do it again. Okay? You only do the chain rule one time as you're working your way in. You don't keep taking the derivative of the same thing over and over and over again. It's like me saying, oh, what's the derivative of x to the fourth? And you're like, oh, that's 4x cubed, which is 12x squared, which is 24x, which is 24, which is 0. I'm like, well, no, that's the first derivative of this is that. That's it. You don't do all this extra stuff here. So don't keep taking the derivative of a function. Take it one time as you're working your way in. All right? Anyway, that's pretty much a 30-minute lesson of using the chain rule and using composite functions to actually take the derivative. All right? That's it, math fans. Adios. Goodbye.